so the third example. Okay, so we have a man who wishes to cross a river and he wishes to go from A to point C and he wants to do it as quickly as possible. Okay, we're given the information that the river is 3 kilometers wide and the distance from C to the point directly across from A, which should be here, is 9 kilometers. All right, he's going to do it by rowing a certain amount and walking a certain amount. Okay, so he can row at 4 kilometers per hour and he can walk at 5 kilometers per hour. What else are we given? I think that is it. So we want to find the time, the minimum time it will take him. So the thing we need to minimize is time. So we need an expression, time equals, and it needs to be in terms of a particular variable. Okay? Actually, yeah. And they also want, the question is actually, what does this distance have to be to make the time a minimum? So we call this distance x. We want to know what value of x will minimize his time. Okay. So we need to get time in terms of x. So the time that it takes him to cross, first of all to cross the river, will be this is the distance, we'll call this distance y, and that's a little triangle. Time is distance divided by speed. So the time it takes him to do this bit is the distance divided by his speed, but the total time is that time added to the time it takes him to walk from D to C. So to walk from D to C, he goes at 5 kilometers per hour. And what is that distance? Well, if this is x from here to here, this is 9, so this bit is 9 minus x. So distance divided by his speed. Okay, now y. This is no good at the moment because we have time in terms of 2 variables. We want to have time in terms of only 1 variable, so there must be a way of expressing y in terms of x. So let's have a look. We have a 3 and an x, so 3 squared, one short side squared plus the other short side squared is equal to the long side squared. So then 9 plus x squared is equal to y squared. Y is equal to the square root of 9 plus x squared, or 9 plus x squared to the power of a half. So the time that it takes him is 9 plus x squared to the power of a half over 4 plus 9 minus x over 5. That's an expression for the time. So if we want to minimize that, we need to differentiate it and find the slope of the tangent and put that equal to 0 and find the value of x that makes the slope of the tangent 0. Find dt, I'm going to call t for time, dt by dx and put it equal to 0. So what is dt by dx? Well, the 4 and the 5 are just constants. They're constants. If you want, you can regard them as a quarter as opposed to being 4. So that's really a quarter multiplied by 9 plus x squared to the power minus a half. So the quarter remains. So we'll just leave the 4. To differentiate this, you get a half times 9 plus x squared to the power of minus a half. Remember, this is a u. dt by du is a half u to the power of minus a half. But because that's not just an x in there, we still have to multiply by that piece differentiated, which is 2x. Plus, when we differentiate this, when you differentiate, you just differentiate the top because the 5 is just a constant. And when you differentiate 9 minus x, you just get minus 1. So that becomes minus 1. Okay, I'm going to rub out and move on. Okay. Okay, so let's tidy that up. Well, we're going to put it equal to 0. Yeah, sure, we will tidy it up first. Okay, a half by 2x by 9 plus x squared to the power minus half. Hopefully it's clear that a half times 2x. When you multiply three numbers together, you can do them in any order. So the half by the 2x just gives you x. So we get x times 9 plus x squared to the power of minus a half over 4 minus 1 over 5. And we're going to put that equal to 0. Okay? Now, let's have a look at this here. That's x. That can be written as x over 4 times 1 over 9 plus x squared, the square root of it. Okay? Remember, 9 plus x squared to the power minus a half is 1 over 9 plus x squared to the power of a half. And I'm just splitting out the x over 4 here. And minus 1 over 5, and we want to put that equal to 0. So let's multiply across to get rid of the fractions. So that's really top by top, so that's just x. And bottom by bottom, so that's 4. Okay? Now, get rid of the fraction by multiplying by 4 root 9 plus x squared. So that becomes x minus 4 root 9 plus x squared over 5. And then when you multiply it over here, it becomes 0, is equal to 0. Okay, multiply across by 5 to get rid of the fraction. So we get 5x minus 4 times the square root of 9 plus x squared is equal to 0. Let's go up here. Isolate the surge, so 5x is equal to 4 root 9 plus x squared. Square both sides to get rid of the surge. Just be careful with the 4. But square both sides, and you get 25. 25x squared is equal to, that's 4 by root 9 plus x squared by 4 by root 9 plus x squared. So you're going to get 16 times 9 plus x squared. So 25x squared is equal to 144 plus 16x squared. Subtract the 16 from both sides and we get 9x squared is equal to 144. Okay, technically we should bring that over, so 9x squared minus 144 is equal to 0. And here we have 3x squared minus 12 squared is equal to 0. So a difference between two squares, 3x minus 12 times 3x plus 12 is equal to 0. That leaves you with 3x is equal to 12, x is equal to 4, and 3x is equal to minus 12. So x is equal to minus 4. Okay, so we now realize that the value of x equal to 4 is the value that makes the time a minimum. And I think that's actually all they wanted. But if they wanted to know the actual minimum time, then you would have to put that value for x back into your original expression for time, which I have rubbed off at this stage. Okay?